This product presentation demonstrates a typical workflow during the development of an electronic assembly and the integration of the design environment with Aras Innovator. First, we will create a new project with a new project command and define the name and the local storage location of the project. When electronics designers start a new project, they begin with predefined templates. The XPLM integration enables the reuse of templates for circuit diagrams or PCB documents, including design rules. The templates and drawing frames can contain predefined parameters as placeholders. Second, after working on a new project, a safe is needed. Preferable, you would like to save your work in a central place, namely in the PLM system. We start the save process in the Integrate menu. The dialog box, which fades in, is the main cockpit for all actions related to creating, saving, and releasing design and manufacturing data. The dialog consists of 3 sections. In the first, you can handle the native design data of the project. In the next section, you control the creation of manufacturing data for the bare board. The last section lists the design variants and enables the creation of the fabrication data for the assembly. Use the Create icons to create a new document in Aras Innovator. The unassembled manufacturing data in the middle section, and the assembly variants in the bottom section. With the Select All button, all output options are checked. And by pressing the OK or Apply button, the PLM data model and all relations between the different objects are verified. The user can follow the progress in the event log and is informed about the status. A further important action is accompanying the whole process: the comparison between the ECAD BOM and the PLM BOM. In our scenario, all parts are marked green because we're uploading the BOM for the first time. RefDes view lists each component sorted by position number, and each design variant comes with an individual BOM which can be unfolded. Use the Show and Hide capabilities to adjust your view. In the Quantity view, components with the same item number are consolidated. The number and the corresponding abbreviations are listed in separate columns. The Missing Parts display shows all design components without a link to a part number in Aras. Use the Unreleased Parts display to see all parts without a release status in PLM. The last display option, Unassigned Parts, lists all components that exist in the current design project but have no entry in the ECAD library. We confirm with OK and start uploading the BOM. With all the actions, we have created the data model in PLM and created and uploaded all documents, such as the native project and the manufacturing data of the unassembled and assembled PCB, including all variants. Without an integration between an authoring tool and PLM, this process would be a time-consuming and error-prone task. With the integration, this becomes quite simple and can be operated by any electronics engineer in no time at all. We are now having a detailed look at all the release data. In the Save dialog, we can directly access Aras Innovator. By selecting the Show button in the Design section, the integration automatically redirects us to the corresponding document containing the native design data. The native design data is filed as a zip file and can be opened when needed. There is the capability to create a PDF of the schematics and release it beside the native design data. This viewer shows the complete logical schematics for the full assembly. In the PDF, all placeholder parameters in the title frames are replaced with PLM parameters. By using the Show button in the PCB section of the Save dialog, we are automatically redirected to the document holding the manufacturing data in Aras Innovator. For the unpopulated board, we created Gerber data, ODB++, or IPC 2581 data as an alternative, drilling information, and a PDF with the production drawing and manufacturing instructions. This viewer shows the PDF containing a drawing of the unassembled board. All placeholder parameters in the title frame are replaced with PLM parameters. Shown next are the zipped Gerber files for the manufacturing of the bare board. The Gerber data can be visualized in this dedicated viewer. For collaboration purposes, for example, a collision checking against the enclosure, Often, a 3D model of the printed circuit board is needed. This viewer shows the step model of the full assembly. The manufacturer's data format, IPC2581, an alternative to Gerber, ensures cross-company and cross-process CAD flow from the PCB design tool to the production with just a single data format. By selecting one of the design variants in the Save dialog and using the Show button, the BOM of the variant is shown in Aras Innovator. Components with the same part number are combined in one line. With opening of a dedicated part number, the individual components are listed with their corresponding reference designators. Let us have a look at the assembly data created in the authoring tool and released to Aras Innovator. This viewer shows the PDF with the assembly drawing of the PCB, including the schematics in one file. For the assembly line, we need coordinate data. This file is usually known as the pick and place file, and additionally includes rotation and other instructions for the placement machine. Finally, this viewer shows the step model of one of the design variants. Our fourth scenario is when components were placed on the schematic of the design which have yet to be created in PLM. We're going to synchronize both systems with the menu entry Synchronize Parts. With the help of the comparison mechanism provided by the integration, this dialog shows information about the differences between the ECAD library and PLM. The components are displayed, and by selecting one, we see that the PLM material number and other attributes are missing for this component. With the Synchronize button, we start the synchronization of the ECAD library with the PLM system. A new material number is created in PLM and assigned to the ECAD component. Usually, electronic engineers define electrical parameters, like a value of a resistor or the tolerance of a capacitor to their components in the ECAD library. Logistical parameters like the release status are available in Aras Innovator. For each parameter, the direction of the synchronization can be individually configured according to the company's needs. This offers electronic engineers and other persons involved in the PLM workflow the most possible flexibility and full visibility on component parameters. Electronic components are usually categorized. They are divided into different classes, such as resistors, capacitors, and integrated circuits. In this dialog, you can access these classes and display their content. We will open a class and select some of the content, followed by the synchronization action. Because the comparison between the ECAD library and the PLM system was carried out, it is still necessary to update the schematic and the layout so that all changes are also reflected in the design. Lastly, after synchronizing, we return to the Save dialog to upload our project to PLM again. This step is necessary because changes to the design that affect the schematics, the board, and the BOM have been made. Normally, a project remains in the processing status until it is finally completed and released. If you would like to make the project accessible to other organizational members, deactivate the Keep Reserve checkbox to set the design status from Locked in PLM to Accessible. In the dialog for the BOM comparison, we have full control about the actual and the previously uploaded BOM. Deactivating the Unchanged checkbox lists all components we newly placed in the schematics. It is now up to the user to upload the BOM or cancel the operation. Confirm with OK to perform a new upload. At this point, we have come to the end of the presentation of the integration between the design environment and Aras Innovator. In case of further questions, please contact us via marketing@xplm.com or www.xplm.com.